Hi everyone, the channel Easy Lecture welcomes you. In this video, we are going to discuss the difference between Fourier series and Fourier transform, or when can we apply Fourier series and when one can apply Fourier transform. So these are the things that we are going to discuss in this video. Before entering into video, subscribe my channel Easy Lecture. Now let us go for further discussion. So in one of my previous videos, DSP made easy, digital signal processing made easy, in a single video I have discussed about all the kinds of transform and their applications. But I have not compared a Fourier series with the Fourier transform, and this video is particularly for that. And we know that Fourier transform, it is used to convert a time domain signal into frequency domain signal, and a time domain signal means the independent variable is time. It is along x-axis, and in y-axis we have the function of time, the signal as function of time. Whereas in frequency domain, along x-axis we have frequency, and along y-axis the signal as a function of frequency, and the time domain to frequency domain conversion is done by Fourier transform. Humankind can understand only time domain signal, not frequency domain signal. So in the receiver side, for the utility purpose, the signal has to be once again reconverted into time domain signal using inverse Fourier transform. Okay, so this is the thing. And why should we convert a time domain signal into frequency domain signal? So this is also we have discussed already. The reason is, in time domain signal many informations cannot be processed, whereas in frequency domain signal we can process a lot of information, and the signal can be utilized, processed, filtered, or whatever the application the signal has to be used, it can be done very effectively if it is in frequency domain. And that is the reason for what we are going for this conversion. Now let us come to Fourier series. To understand Fourier series, we must understand one concept, that is, any periodic signal is a combination of infinite number of sinusoidal signal. Okay, so when we speak about sinusoidal signal, it may be either sine waveform or cosine waveform. So this is sine waveform and this is cosine waveform, which we know already, the difference between sine waveform and cosine waveform. So these two signals are called as sinusoidal signal. Okay, so any periodic signal is the combination of infinite number of sinusoidal signal, means the signal can be represented in three variables. So it has three parameters. Okay, the three parameters are amplitude, frequency, and phase. Okay, so let us consider like this. We have infinite number of sine waveform, and all the sine waveforms, they do not have either one of these, they do not have same amplitude or same frequency or same phase or the combination of any of these three things. Okay, so in that case, if we add all these infinite number of these sine waveforms, the resultant waveform will be a single periodic signal. So this is the concept, this concept we must know. Okay, so this is the thing. If we take infinite number of sine waveform varying with amplitude, or if we take infinite number of sine waveform or cosine waveform varying with frequency, or if we take infinite number of sine waveform or cosine waveform with varying in phase, or combination of amplitude, frequency, or phase, in any of these things. If the thing is, if we add all these infinite number of sinusoidal signal, the resultant will be a periodic signal. And the periodic signal necessarily it is not required for the periodic signal to be a regular shaped periodic signal like square waveform or sawtooth waveform or triangular waveform. It can be even an irregular shaped periodic signal. So irregular shaped periodic signal means in the fundamental period the shape may be irregular, but after every fundamental period, when the fundamental period repeats, the signal also repeats itself, the same irregular shape repeats itself. So this is the thing. Anyways, the signal is going to be periodic. So this is the thing. Okay, so in Fourier series, reverse engineering is done there. So what does it do? it tends to find what are the infinite number of sine waveform or cosine waveform, or what are the infinite number of sinusoidal signal being hidden in that periodic signal. So that is found by Fourier series. So this is the main difference between Fourier series and Fourier transform. Here Fourier series, it does not do any transformation. So for Fourier series to happen, the signal should be a periodic signal. So that is the reason why we can apply Fourier series only to a periodic signal and not to any aperiodic signal. Okay, and Fourier transform, it can be applied to periodic signal and also aperiodic signal. So many of us may have confusion, have misconception related to that Fourier series can be applied to periodic signal and Fourier transform can be applied to aperiodic signal. So it is not like that. The concept is entirely different. Of course, difference between Fourier series and Fourier transform exists, but it is not in that way. It is in this way that Fourier series, it tends to find the infinite number of sinusoidal signal hidden in any periodic signal, whereas Fourier transform, it transforms the time domain signal into frequency domain signal. Okay, so I hope this video might have help you to overcome the misconception about Fourier series and Fourier transform. Meet you again in another video. Until then, bye. Don't forget to subscribe my channel. Bye. Take care.